Okay, welcome to all. So today I think your friends they have completed the experiment. Okay, so I am really happy to Gautam, Aparajita, Shaptarshi, Biraj and Shondip. They have successfully demonstrated the complementary pulses and also the dead time generation, and also how to change the PWM frequency by changing the prescaler bits, and that video it is in my channel, you can see that. So today we will be learning about how to generate sine PWM, because we are going to generate finally the AC signal from DC by switching it. So this duty cycle, already you have learned how to generate the pulses with fixed duty cycle. Now every PWM cycle, the duty cycle will be changing. And how it will be changing? It will be changing with a sinusoidal fashion. Means first duty cycle will be say sine 1 degree, then it will be sine 2 degree, 3 degree, like that. Duty cycle will be a function of sine theta. Okay, so let us see how to do that. আমার স্ক্রিন দেখতে পাচ্ছিস সবাই? আমার স্ক্রিন দেখা যাচ্ছে?
Yes sir.
আরে চুপ করে বোবার মতো হয়ে বসে থাকবি না। আমি একটা কথা বললে কেউ যে কোনো একজন উত্তর দিবি। Okay, so now the duty cycle, as I told, the duty cycle this will be the duty cycle should be a function of sine theta, into the resolution. Say the resolution is 1024. So it should be like this. But here one thing you should remember, that this sine theta from 0 to 90 it will be positive, absolutely no issue. But from 90 to 180, from 0 to 180 it will be positive, but 180 to 360 the sine theta value is negative, so this will go negative actually. So negative is not entitled, because duty cycle can't be negative in the microcontroller. So you have to give one DC shift. Say if I plot this function, okay, so these things it will be 1024, and this will be minus 1024. If I plot basically this function, theta is 0 to pi, so from 0 to 2 pi, from 0 to pi it will be positive, and from 0 to 2 pi it will be negative. So to do that you have to give a DC shift, you have to give a shift. If I add with this 1024, so what will happen? This will go up, but the resolution means the maximum peak will become at 90, maximum peak will become 2048. but it will cross the resolution, so you have to divide by 2. This you have to divide by 2. So if you do that, then it is now restricted to the sine wave. Now it will be restricting and it will be oscillate between 0 to 1024. Okay, so now finally I will be writing the function duty cycle. It should be duty cycle, it will be resolution by 2 into sine theta plus resolution by 2. And if I rotate a for loop, that theta is 0 to 360 degree, then my duty cycle will be varying in a sinusoidal fashion. Now how to define the counter of the for loop? How to define the counter of the for loop? So now you already understood, you already familiar with the PWM frequency. Okay, say the PWM frequency or the switching frequency is Fs, and now my power frequency is F, which is 50 Hertz. So to make my power frequency, how many switching frequencies to be elapsed? That is F by Fs. So now my for loop will be rotating from 0 to F by Fs. Let us take one specific example to understand it. So already that Saptarshira, whatever that experiment done today, so initial frequency was 3. First frequency was how much? 7.8 1 2 around 0.5 around something. So this is my switching frequency divided by my power frequency. So 156 number of PWM cycle, if it is elapsed, then only my cycle will be full 0 to 360 will be completing. So this value, sorry, this is Ts, this is T by Ts. So now this value we obtained, it is around 156. Power frequency means our line frequency, it is 50 Hertz. Okay.
So we are supplying this is the output that we want to get.
Yes. So now my sine theta will be splitted to 156 fold. That means each step I need the value of, so first is 0, then I want theta value. So here theta, if I put the theta, that theta is equal to 360 divided by 156. Now if I rotate a for loop, I is equal to 0 to 156, okay, and my duty cycle, if I put, say my duty cycle is say my resolution is 10 bits, so 1024, what I told, resolution by 2, that means 512 into sine I theta, sine I theta plus 512, resolution by 2. If I rotate these things from I is equal to 0 to 156, then my sine wave is, my duty cycle will be varying in a fashion of sine theta, and as well as my 50 hertz we will be obtaining. It's very simple, okay. Another thing to optimize that, now you see, you can optimize the code. So this is your sinusoidal signal. Basically this is, you know, sine wave is a odd symmetry. So that means 0 to 90. So my this total split up will be 156. This will be 156 by 2, and this will be 156 by 4. Okay. No, total will be, total step is 156. So this will be 156 by 2, correct, and this will be 156 by 4, that many steps. Now if you can, rather than writing the entire sine theta value, because it will be unnecessarily occupying the flash memory of the controller, so you just write the value of 0 to 90, then 0 to 90 it will increment it, then 90 to 180 you decrement the array, then 180 to 270, the same array in the first half you just give the negative sign, and for 270 to 360 you just give it negative sign of the second half array. Your sine wave can be formed in this way. So you can optimize the code rather than writing the entire array. But here I have shown you, I will be showing you with the full array. But while you will be doing the experiment, you can define a user defined function of sine theta in this way, what I told. You see here the array element, I have defined one array A. This is basically the sine theta, and these elements are 156. What I told, now you just write up to 156 by 4, that many elements, and by altering by proper manner you write a user defined function of sine theta using that 0 to 90, then you use that array. Here everything you are already familiar, these are all you are familiar. Now you see what I am doing. Say my dead time is, I have calculated the dead time as 20, okay. So now you see here I am defining a variable called complementary duty, and here it is 10 bit. So arbitrarily I taken 500, you can take up to 511 or 512. So always it is better to take slightly lesser. My teacher, your teacher, Ayon Banerjee, I think he is there, he taught us in that way. So you see here that always you need not to put the full resolution. Okay, so that's why I given here 500. And you remember the formula I told, resolution by 2 into sine theta plus resolution by 2. So this is basically that formula, and minus 20. Okay, but sometime you see this value will come lesser than 20. That time duty cycle go negative, which is not acceptable. So for that I written these two conditions. If that value is going greater than 0, then I am not changing it. It is as it is. But if it is less than 0, then I am restricting to 0. I am not allowing it to go negative. Okay. So after that I am giving the non-inverting pulse duty cycle is that same, and the inverting duty cycle pulse is this one. Means till it is positive, no change, but till it's go negative, when it will go negative, it will be restricted to 0. And here what I am doing, you see, after that here I have initialized, this is the array argument I am giving I, and here you see I have initialized the value of I to 0, and what I told, I have splitted the entire 360 degree by 156 times. So once it is go beyond that, again one fresh cycle will start. So if my counter value, means the array index value, is crossing 156, again I am initializing it. I am resetting it. In this way I am getting my duty cycle. Now let us see what is the whether whatever now whatever you coded, is it giving the output or not?
Why is this affecting me?
Huh?
Why is this affecting me?
Why I have to?
I just wait.
That is the dead time.
So that is the dead time. So why are we taking values which is less than the resolution?
No. I am not taking the less than the resolution. You see, that will be, our resolution is say 512. 512 into 2 means 1024. So I am just taking 1 or 2 count less. It is always better. Rather than going to extreme, I am taking some 1 or 2 counts, 5 counts lesser. It will not matter. For small inverter it is not a matter, but for big inverter where the voltage level is high, there may be significant these things. That time you have to consider it. So you see the same thing, and here I am using a RC filter. So you have to use that RC filter. While you will be doing that experiment, you have to use one RC filter. You know, for RC filter cutoff frequency, how to do it. So your 2 pi fc, your 2 pi f is equal to 1 by RC. So using that, your cutoff frequency, because my power frequency is 50 Hertz, so I want to filter it out. All the higher frequency should be filtered out. Only allowable frequency is 50 Hertz. So for a low pass filter, my 2 pi f is equal to 1 by RC. From this formula you can find out what should be R and C. You see here, this R and C, if you multiply and if you reverse, okay, then if you multiply by 2 pi, it will come 50 Hertz only. You see that, এক মিনিট এখানে দেখ, এই A and B are the complementary pulse, and one pulse I have filtered out, and that I am giving in channel C. So you see, so B channel is basically channel B. Channel B is which color? Channel B is that blue color. So this blue color pulse is basically filtered. So now if I increase the amplitude, এটার amplitude যদি একটু বাড়াই, slightly I will increase, and this I'll shift it in top. And now I will pause. Pause করে কি করে, এই যে pause করলাম. Now if you see the exactly, if you see here one peak, this peak is 21.95, মানে ধরে নে 22 millisecond, and here you see it is 0, so it is around 20 millisecond. 20 millisecond is 50 Hertz. So basically we will be giving the pulse in this fashion, and finally at the output we will get the sine wave. This is our main final output of the project. Let us slightly extend further. এটা বেশি বড় হয়ে যাচ্ছে, এই দেখা যাবে না. You see this pink color, basically when it load will be there at the output, so basically the inverter output will be filtered out and we will be getting the output like this. So this is the all about today's class. You hope you understood, who have done the experiment today, so they have understood it better way. Other people also understood, but who have done the experiment, they will be conceptualize the things better way. Anyway, it doesn't matter. So this is the thing. So now I'll first stop the recording because it's getting slow. Then I will answer your question. Any doubt is there or not? Thank you so much. Thanks for your patience.